Do you think the world you see is absolutely real? This video might completely overturn your understanding of reality. And it all starts with a scientific revolution from the last century. At that time, physicists were caught in a question that seemed simple, yet turned out to be profoundly deep. Is light a wave, or is it a particle? To solve this mystery, they designed a groundbreaking experiment, the legendary Double-Slit Interference Experiment. They directed a beam of photons at a device with two narrow slits. According to classical particle theory, each photon would choose either the left or the right slit, and then form two clear clusters on the screen behind the slits. But what if light is fundamentally a wave? In that case, the wave would pass through both slits at once, interfere with itself like ripples in water, and leave not just two spots, but a series of alternating bright and dark stripes on the screen. The bright areas represent constructive interference, where waves add up. The dark areas represent destructive interference, where waves cancel each other out. The experimental results shocked everyone. When photons were emitted continuously, a classic interference pattern appeared on the screen, exactly what the wave theory predicted. This result strongly supported the idea that light behaves like a wave. But what truly baffled scientists was what happened when they lowered the emission frequency so that only one photon was released at a time. Even then, the interference pattern slowly built up on the screen. In other words, even with a single photon, it somehow knew both slits were there, as if it passed through both slits at the same time, existing in a superposition. This completely challenged our understanding of what a single object really is. To find out which slit the photon actually passed through, scientists installed detectors in front of the slits. The results stunned everyone again. The moment they tried to measure which path the photon took, it would only go through one slit, behaving like a particle. At the same time, the interference pattern on the screen mysteriously disappeared, replaced by just two simple spots. This meant that the very act of observation was enough to change the result of the experiment. The photon no longer behaved like a wave. It had chosen to become a particle. Its superposition collapsed into a definite state. Observation was no longer a passive act. It became an active part of shaping reality. This is the famous wave-particle duality. Light is both a wave and a particle, and how it behaves depends entirely on how we choose to observe it. At this point, the issue is no longer just about photons. It's about our entire understanding of reality itself. This strange behavior brings to mind Schrödinger's cat, a cat sealed inside a box, whose life or death isn't determined by itself, but by whether we decide to open the box and look. Before observation, the cat is both alive and dead, existing in an uncertain state. That cat is a real extension of quantum logic into the macroscopic world. But what truly shattered humanity's view of the universe was physicist John Wheeler's delayed choice experiment, proposed in 1978. In this experiment, the photon passes through the double slits, but is not observed right away. Instead, scientists wait until the photon is just about to reach the screen to decide whether or not to observe its path. Astonishingly, no matter when the decision is made, the photon's earlier behavior is affected by that later choice. In other words, a decision made in the future can influence the state of the past. The solid cause and effect logic we take for granted completely breaks down. Time is no longer a simple, linear sequence. In the microscopic world, time and reality are not objective, fixed things. They are deeply entangled with our consciousness and observation. This isn't mysticism, and it's certainly not speculation. These are hard quantum facts, repeatedly verified through countless real experiments. As Niels Bohr once said, no physical quantity is real until it is observed. That statement alone is enough to shake the very foundations of modern science. We used to believe we were mere bystanders in the universe, but now we understand. Our actions, our choices, even our gaze, are all part of the construction of reality itself. Bohr didn't just study quantum theory. He was also deeply fascinated by Chinese philosophy, especially the Taoist concept of yin and yang. He even chose the Tai Chi symbol as his family crest. To him, the Tai Chi represented quantum mechanics, two states coexisting, constantly transforming, neither dominant nor subordinate, with no beginning and no end. Inside that ancient symbol lies a question that modern physics still cannot escape. Each time we observe something, each decision we make might actually be creating part of what we call reality. So let's return to the original question. Is the world you see truly real? Can the things you believe in really exist independently of your own awareness? Quantum mechanics doesn't give a clear answer. It simply tears apart the certainties we once believed to be absolute. In this world, certainty is no longer reliable. Objectivity becomes fragile, and reality might just be the result of our continuous interaction with the universe. And that interaction is happening right now.